Okay, let's talk about something we've all wondered about. Why do those incredible, vivid dreams, the ones that feel so real, just evaporate the second we wake up? It's one of life's little mysteries, right? Well, today, we're going to dig into a really wild new idea that says the answer isn't in psychology, it's in physics.
I mean, you know the feeling. One minute, you're flying through the sky or having this super intense conversation, and the next, you're awake and the memory is just slipping through your fingers like smoke. You try to grab onto it, but it's just gone. So what if we've been looking at this all wrong? What if it's not about how our brain saves things?
And that's exactly where this new model of the mind comes in. It basically argues that we've been using the wrong metaphor for years. Our brain isn't some computer, saving and deleting files. It's more like a dynamic energy field, playing by the rules of physics.
Okay, so to really get this, we kind of have to reset our whole idea of what the mind even is. So let's start with this new perspective, thinking of your mind as a literal field of energy. For like decades, we've had this idea of the brain as biological hardware running memory software. But this new model, called the Brain Kinematics Model, or BKM, says we need to just toss that idea out. It wants us to stop thinking about stored files and start thinking about, well, patterns of energy, kind of like ripples spreading across a pond.
So what's this energy field actually made of? Where does it come from? Well, according to BKM, it's the constant chatter between three physical layers. You've got the electrochemical signals from neurons firing, the electromagnetic brainwaves that get them all in sync, and even the physical stress and strain on the brain tissue itself. And here's the kicker. A real thought, a real memory, only happens when all three of these layers lock together in perfect sync.
All right, so if the mind is an energy field, then what in the world is a memory? Turns out it's not a thing you store, it's a pattern you create. Let's see how that actually works.
In this model, a memory is basically a stable pattern. It's a specific shape, a geometry of energy that gets created when those three layers synchronize just right. The best way to picture it is like a standing wave in water. It holds its shape, its structure, even as everything else moves around it. That stable pattern is the memory. It's not stored in the brain, it is a state of the brain.
And this wave idea, it explains the difference between types of memory so well. Think of a long-term memory like a big, deep rolling wave. It's super stable, doesn't take much energy to keep it going. But a short-term memory, that's more like a tiny, fast ripple on the surface. It's got a lot of energy, but poof, it's gone in a second. Fragile.
All right, so we know what a memory is. It's a wave pattern. But how do we actually, remember it? How do we summon that specific wave back into existence? Let's get into the physics of it. Now, this is the part that changes everything. Remembering isn't about going into a filing cabinet in your brain and pulling something out. It's an active process of reconstruction. You are literally recreating the specific wave pattern of that memory. And this physical process has a name, re-coherence.
And it happens in three steps. First, some new thought or feeling acts like a tuning fork. Its vibration matches a stored memory pattern. That's called resonant matching. Then the brain's three energy layers hear that note and they all start to synchronize, locking into that old pattern. That's phase entrainment. And finally, the whole pattern gets amplified. Its energy goes up and boom, the memory just pops right into your head. It's been physically rebuilt from scratch.
So if remembering is all about recreating a wave, you can probably guess what forgetting is. And this, my friends, brings us right to the heart of our mystery, the physics of just letting go. This quote from the model just says it all. Forgetting is energy redistribution within the same continuum. So what does that mean? It means memories don't get deleted like a file on your computer. Forgetting is just what happens when the energy that was holding that wave pattern together gets, well, redistributed. The wave dissolves, and its energy just flows back into the system, ready for the next thought.
And that brings us right back to where we started. With these new ideas, the brain is an energy field, memories as waves, and forgetting is rebalancing, we can finally solve the mystery of the disappearing dream.
So here it is. Here's what's happening. When you're dreaming, your brain is creating these really delicate, fragile wave patterns. But the instant you wake up, your brain physically switches gears into a totally different state, a powerful, high-energy pattern that you need for conscious thought. And this new, strong, awake pattern doesn't just hang out next to the dream pattern. It physically overwrites it. It's like a tidal wave washing over a tiny ripple. The dream's delicate structure just collapses instantly.
So, let this sink in. Forgetting a dream isn't a bug. It's not a failure of your brain's save function. It's a physical phase transition.
just like liquid water turning into steam. One energy state is physically replaced by another, and the old pattern just can't exist in the new environment. It's physics, not a flaw.
And this isn't just about dreams. This applies to all kinds of forgetting. About half the time, it's just gradual decay, as a memory's energy kind of fades over time. Around 30% is that abrupt collapse we see with dreams, and the last 20% is actually really cool. It's adaptive forgetting, where your brain intentionally lets go of old, useless patterns to make room for new, more important ones. It's not a bug, it's a feature.
So you can really see the whole life of a memory as this continuous dance of physical properties. When you learn something, energy rises and a pattern forms. When you remember it, that energy rises again to reconstruct the pattern. And when you forget, the energy just declines and gets redistributed. See? It's not a static library. It's a living, breathing, constantly changing system.
And what I love about this is how it explains all these little things we feel every day. That tip of the tongue feeling. We've all had that, right? Well, that's your brain achieving near resonance. It's so close to recreating the wave, but the coherence just isn't locking in. A sudden memory that just pops into your head out of nowhere, that's a rapid, perfect resonance match. This isn't just theory. It's like a new language for our own experiences.
And it all comes down to one single overarching rule, the continuity principle. The whole idea is that the brain is always in motion, always trying to find an energetic balance. It's constantly shifting between these stable, efficient states and these more adaptive, let's figure stuff out states. Every single thing your mind does is part of this fundamental search for equilibrium.
This just wraps it all up so perfectly. To remember is to re-enter coherence. To forget is to redistribute it. Remembering and forgetting aren't opposites, and they're not enemies. They're two sides of the exact same coin. They are the natural rhythm of the mind.
Which, of course, leaves us with a pretty big, kind of mind-bending question. If our entire inner world, our memories, our dreams, our sense of who we are, is all just physical patterns of energy, constantly forming and dissolving in a search for balance, then what does that make us? Something to chew on.